Question 3 is also a derivative. I included this because of the exponential functions. I see that some students have difficulties taking derivatives of exponential functions, and I made this one also a quotient. So we're going to use a quotient rule for derivatives, along with the chain rule. The quotient rule says the derivative of the numerator divided by the denominator can be found by taking the derivative of the numerator multiplied by the denominator minus the numerator times the derivative of the denominator, and then that's all divided by the denominator squared. So in this case, our numerator is 4 plus e to the power of 2x minus 3. The denominator is e to the x plus 4 minus 2. Here I just wrote it out using the quotient rule. And then when I start taking the derivatives, the derivative of 4 plus e to the 2x minus 3, well, the derivative of a constant is 0, so that 4 will drop out. And the derivative of the exponential will bring back that exponential times the derivative of the exponent. And so I'm going to get e to the 2x minus 3 times 2 for this first derivative in the numerator, e to the 2x minus 3 times 2. That's multiplied by the denominator, e to the x plus 4 minus 2, minus the numerator, 4 plus e to the 2x minus 3, times the derivative of the denominator. And so the derivative of the denominator is going to give me back that exponential, e to the x plus 4, times the derivative of the exponent, which is 1, and then the derivative of negative 2 is 0. So on that derivative of the denominator, I just get e to the x plus 4. And that's over the denominator squared. So the question is, can I simplify this? And you might look to see if you could factor the numerator. And yeah, you could factor it, but with all of those strange looking exponents, what I did is I simplified by removing parentheses, and then I looked for like terms. So to remove parentheses, this first set of parentheses, you're going to multiply by 2e to the 2x minus 3. And when you multiply e to the 2x minus 3 times e to the x plus 4, you add the exponents, which will give you 2x plus x gives you 3x, and negative 3 plus 4 gives you a plus 1. And then when you multiply this 2e to the 2x minus 3 times 2, you get 4e to the 2x minus 3. For the second term, remember that you're distributing through by that negative as well. So you get negative 4e to the x plus 4, and you get negative, and then adding these exponents again, you get e to the 3x plus 1. And notice that you have an e to the 3x plus 1 term in common. So combining those, you've got 2, take away 1 of them, it'll leave you with 1 e to the 3x plus 1. So I get e to the 3x plus 1 minus 4 e to the 2x minus 3 minus 4 e to the x plus 4 all over the denominator squared. If you want to, you can multiply out the denominator. I do not think that this will reduce at all. If you want to, you could factor from the numerator, you've got an e to the x. You could factor on an e to the x minus 3 to bring that out in the front. But I don't think that's going to leave you with anything that you can really do anything with. And so I just left the answer like this.